All right, listen up, junior engineers and site supervisors. Welcome to this explainer. I've spent, 2 decades inspecting high-rise construction sites, and if there is one thing I see misunderstood time and time again, it's the concrete slump test. Today, we're not just doing some basic textbook review. We're going through a field-hardened masterclass. As the site inspector, you are the structural gatekeeper. Your understanding of this exact test is what stands between a building that lasts a century and a catastrophic multi-million-dollar failure. Today, we're running through 5 standard operating procedures. We've got the burden of command, the WC ratio threat, flawless execution, true, shear, and collapse profiles, and finally, commanding the job site. Let's dive right in. Section 1. The burden of command. You are the gatekeeper. Okay, we need to completely shatter a massive misconception right out of the gate here. Slump measures consistency. It does not measure strength. I hear it all the time on site, right? Someone just assumes a low slump automatically means high strength, or vice versa. It doesn't, period. The slump test is your primary indicator of workability and consistency. If you misunderstand that difference and you let a batch with bad consistency get placed, well, you're actively destroying the final structural integrity of the build. So let's hammer this home. Consistency absolutely does not equal strength. You are measuring consistency purely as a diagnostic tool. Think of it as your early warning system. It's there to detect if the mix is out of balance or, honestly, more commonly, to prevent unauthorized on-site alterations to the mix design before the concrete is ever even placed. Moving to Section 2, the water-cement ratio threat, preventing structural failure. Let's ground this in a situation you'll face all the time, a really relatable, high-stakes confrontation. Why are you constantly fighting the pump operator or the placing crew over adding water to the hopper? Look, they want to add water because it makes the mix flow easier and faster. It makes their physical job easier. I get it. But you absolutely have to stand your ground and say no. Why? Because of what that water literally does to the internal structure of the concrete. The science behind your refusal comes down to this right here. When you exceed the optimal water-cement ratio, which is usually between 0.35 and 0.45, that excess water doesn't just magically disappear. Once the cement hydration process finishes up, that extra water evaporates and it leaves behind this nasty network of interconnected capillary voids. This drastically increases the concrete's permeability and carbonation depth over time. So you aren't just making it weaker today, you are virtually guaranteeing it will rot from the inside out over the next 20 years. No way. Let's break down Abram's law here. Just take a look at that middle row for a second. An excess water addition that increases the water-cement ratio by just 0.1, that results in a massive 15 to 20% reduction in compressive strength. Let that sink in for a second. A 15 to 20% strength drop. That is literally the difference between a column holding the design load and a column completely failing. High water ratios also lead to decreased cohesion, massive porosity, segregation, and honeycombing. And this is exactly why you fight the pump operator. All right, Section 3, flawless slump test execution, precision under pressure. Now, from dampening the mold and filling it, all the way to the final lift, you have exactly 2.5 minutes. That's it, 2.5 minutes. You have to be organized, you have to be totally ready, and there is absolutely zero room for hesitation. These are your absolutely non-negotiable steps. First, fill the cone in 3 equal volumes. And remember, guys, that's volumes, not equal depths, okay? Second, rod each layer exactly 25 times, and you must use a standard 5/8-inch hemispherical rod. When you're rodding the second and third layers, that rod must penetrate exactly 1 inch into the previous layer to properly bind them together. Finally, lift the mold straight up, 12 inches in exactly 5 seconds. Well, give or take 2 seconds, but aim for 5. Now, I need to deliver this next bit of field-hardened advice pretty strictly because I've seen it violated 100 times. Never, ever tap the outside of the cone to consolidate the sample. Just don't do it. Do not let anyone hand you a piece of scrap rebar to use instead of your hemispherical tamping rod. Rebar has flat, jagged ends, right? It pushes the aggregate down and completely ruins the consolidation, making the entire test completely void. And when you lift that cone, absolutely no twisting or lateral motion, straight up, every single time. Let me just reiterate this because there are zero shortcuts here. If the slump cone is tapped, moved, or disturbed during the test, the sample must be discarded and the test starts over. That's the rule. If a laborer accidentally bumps your base plate, you throw the concrete out and you start again. Period. No exceptions. Moving on to Section 4, True, Shear, and Collapse, Diagnosing the Structural Mix. Okay, these are the 3 slump profiles you absolutely must memorize to evaluate how the concrete is going to behave once it's actually in the forms. We're looking at true, shear, and collapse. First up is the true slump. This is where the concrete settles straight downward and remains mostly intact. You'll see the sides bulge out slightly, but the center stays in orientation. This is your visual confirmation right here that the mix is cohesive, the aggregate and paste are well balanced, and hey, it's ready for placement and predictable consolidation. Next is the shear slump. This is where the top portion literally shears off and just falls away to one side. If you see this, the test is completely meaningless. It indicates a severe lack of plasticity in the mix, which is often due to low paste content or a highly unbalanced sand-to-aggregate ratio. Your mandatory field action here is to immediately discard the sample and demand a retest from a brand new portion of the batch. And finally, the collapse slump. The sample completely fails to hold its shape and just sprawls out all over the place. This is a massive red flag. It means the mix lacks cohesion entirely, and it almost always means the water-cement ratio is far, far too high. If you see a collapsed slump, you must immediately halt placement and investigate because that concrete is severely compromised. So, to sum up your diagnostics here, a true slump provides a meaningful result and allows you to proceed with measuring and reporting. But if you get consecutive shear or collapse slumps, those are invalid results. It simply means the concrete lacks the fundamental plasticity required for the ASTM C143 method entirely, and honestly, the batch is just fundamentally flawed. All right, last section. Section 5, Commanding the Job Site. Professional integrity. These are your core field-hardened duties out there. You are the ultimate gatekeeper against unauthorized water. You use your visual examination of that slumped concrete as a highly powerful diagnostic tool to catch segregation early, long before it turns into honeycombing hidden inside a hardened column. You don't just mindlessly fill out a checklist. You rely on predictive troubleshooting. And your default action, whenever there's even a shadow of a doubt about a test, is to discard it and rerun it immediately. I really want you to remember this next point every single time you pick up a pen on the job site. When you sign that testing report, you own that structure. Your signature is literally the final line of defense for structural compliance. If that building fails 5 years from now because of a high water-cement ratio, your name is on the paperwork. So test strictly. So I'm going to leave you with this final thought to take with you on your next inspection. When the pump operator is yelling at you, the foreman is rushing you, and the schedule is running behind, are you prepared to stand your ground, reject a compromised batch, and protect the structure? Because that is exactly what it takes to be a true master of the concrete slump test. Thanks for joining this explainer. Now get out there and command the job site.